there are two things I want to highlight in this patch for you. The first one is just that this is doing the audio analysis automatically. So it's doing that sort of, automatic analysis rather than having to click a bunch of times and add all the points. It'll automatically create these data sets. So look in there and poke at that. But more importantly, I actually want to talk about this question of validation. So when we train these neural networks, there's a tendency, train the neural network and then be like, great, it's trained, it's done, use it. Yay, it works, we're done. But actually, there's a really important step that we might want to try to do to make sure our neural network is really working properly. And that step is called validation. And we're literally going to validate, is the neural network doing the thing that we want it to do? Now, when we looked at the MLP regressor and we were controlling the synthesizer, the validation is essentially that activity. Move the dot around. Does it sound good? Does it feel like a performance instrument that I would want to use? When we're doing something like classification, we can actually be a little bit more thoughtful about it and try to really identify numerically, like, is it making accurate predictions? And so one way that we might do this is we might take this validation patch, which will do it on some sounds that I have created, I have these 4 folders of sound. I have a folder called distorted noise, high squeal, low impulses, sustained noise, quiet. You can see them here. And in it, I have some sound files. So this is maybe, a few minutes per folder of audio. And these are just examples of these different categories of sound that I want the neural network to learn to predict. And so I'm going to use this automatic analysis system to create these 4 data sets. One is going to be my MFCCs for training and my labels set of labels for training. And another one is going to be a data set of my MFCC analyses for testing and my labels for testing. And what I'm doing here is I'm making these 2 input-output pairs. One set of analyses and labels that I'm going to train the neural network with, and then a different set of analyses and labels that I'm going to test the neural network with, and they don't overlap. So when I do the testing, I'm actually testing the neural network on these audio analyses that it has never seen before. The way that I'm generating those 2 different sets of data is I'm actually just randomly flipping. So 20% of the time I add it to the testing set, and 80% of the time I add it to the training set. So you can see that that's where this is happening here. So if I make these data sets, I can do that by send in these messages, and it's doing the analysis on each folder and then adding it to these data sets. So now if I print them, we can see that. So I have a label set for testing, labels test, that has 508 data labels in it. And then a data set for MFCCs for testing, that has 508 data points in it. Then I also have a label set for training that has 2,000 labels in it, and a data set of MFCC analyses for training that has the 2,000 analyses in it. So now what I'll do is I will train the neural network with it by doing this. See how the error changes here. It's going down, that's good. Started really low, so we don't really see it moving there, but training on 2,000 data points, so it takes it's a little bit of a hiccup there. Have it do all that training. Okay, looks like we're doing pretty good here. So I did the training with my MFCCs train and my labels train, and now I'm going to make a prediction with all of the data points in MFCC test and labels prediction, which is another label set here for these predictions that it's going to make. And then it's telling me that out of the 507 data points in my testing set, I got 0 incorrect and 100% correct. It had 507 correct. So that's actually really good. I shouldn't have trained it quite as far. Let me clear it and then fit it again here. Oh, still 506. Clear, fit. Well, there we got 1 incorrect. This, well, the neural network is working really well. It's training very nicely. But yeah, this is a way that we can validate it and see for the 508. I'm not sure why it's only doing 506 here. It's weird. Before the 500 or so, labels and audio analyses in my testing set here, I can see how many it gets correct, how many it gets incorrect, and then what the percentage of correct is. And so this would be a way for me to validate my training and see if this MLP classifier is actually how accurate it is being, right? Because I don't really have a percentage of accuracy based on this sort of error value here. That's not what this is representing. I'm going to see if I can get it to do a little bit more poorly. Let me clear this. There we go. So now I got 22 incorrect. My error is also much higher. You can see that there. If I train it a little better, the error gets a little lower. Now I have only 8 incorrect. Fit it again. 3 incorrect. 2 incorrect. And eventually we'll probably get back down to that 0 incorrect. This is a highly successful training, in part because the MLP classifier does a good job, but also in part because these are really clearly defined sounds. And so this MFCC analysis is really able to learn, really able to identify those differences, and then the neural network can really learn those differences. One reason why you might get not as successful of results is if you're trying to train between different categories that are not that different, right? And so this is a way for you to realize, like, okay, you know, this doesn't seem to be working. I have a certain like percentage of correctness here that might be useful. And you can also start to reflect on, okay, well, maybe these are too similar. Maybe I need to think more about what I'm asking the neural network to do. Maybe there are some different audio analyses that might be better for determining the difference between these sounds. What are the differences in the sounds that I really hear? What are the differences in the sounds that I really want to identify, right? And so this is not just a good thing that's like, well, let me like validate and see if it's good or not. It's not good, bummer, or it's good, great. It's also a tool to sort of reflect on what is my data that I'm actually trying to classify between. What is the analysis tool that I'm actually classifying with, that I'm actually doing the analysis with, right? How might I tweak other parts of the process to improve the validation here? So that whole pipeline is an important thing to reflect on.